Welcome back. So here we're going to end up having this setup where they say example 4, but ultimately what they're doing is they're just proposing the theorem and describing how it was justified or how it was proved, or asking you to go through a series of questions to understand the proof itself. And so in example number 4, it says the construction and claim together implies the following theorem. So in other words, you've just proven it through your construction and the claim, but theorem, given line L and point P not on line, there exists an image that contains P and is parallel to L. So this is a theorem, and essentially it's the original construction. I start with a line with a point not on the line, and I can construct a line that's parallel to the original line. This theorem we have just justified before using compass and straight edge constructions, but now we're really going to see how it comes together, and that's through basic rigid motions, which, if you remember, was our objective, and geometry assumptions. So example 5 sort of indicates this. Now that we're ready to prove the first part of our basic fact, we have two lines, L and L prime, and we all know that the transversal AP intersects line L and line L prime such that there is a pair of alternate interior angles equal in measure. So that's the claim, that when I intersect these parallel lines with a transversal, that the alternate interior angles are equal in measure. So again, they're going to state that C is the midpoint. You guys constructed that before, so you've got to go back to your construction and kind of look at it. What happens if you rotate it 180 degrees about the center C? Is there enough information to show that the image of L is L prime? And in essence, they're just asking you to kind of rotate this and make sure. Okay. The answer on the following page are the prompts that will help you sort of go through this proof. And so first things first is it says, what is the image of the segment AP? Since there was a rotation about midpoint C, and there's a lot of information just embedded in the fact that this is a midpoint. In other words, that A to C and C to P are equal distances. A maps to P and P maps to A with a rotation centered at C of 180 degrees. One thing being is that the 2 points define the line that C is part of. So in particular, what is the image of the point A? Point P is the image of point A. Okay. The next question requires a little bit more thought. Why are there points Q? And this is really can be reworded as the image of B on the same side of the line AP. And if you go back to your drawing, you had this thing that was AP. Okay, and you had C, B here, and Q over there. And so what it's really asking are, why are the points Q and the image of B on the same side of the line AP? And it all stems from the fact that you are using C as your center point. It keeps an equal distance, and you've rotated 180 degrees, because what rotating 180 degrees does is brings you to the opposite side. So since B is on the opposite side of AP with C the center of rotation. Okay. In other words, C is the only point that's going to map directly back onto C. The question is, what happens? How does B flip-flop to the other side? So since B is on the opposite side of AP with C the center of the rotation, we know rotations of 180 degrees map to the opposite side of the center point, which is C. So I'm mapping B to the opposite side of the center point C, which is included in AP. In other words, B's image has to go to the opposite side of AP. So that was pretty intense. Suggestion is to pause the video right now, go through this, highlight, annotate, write down any questions you may have, email me fairly soon. D says, what is the image of the rotation of this angle BAP? So if I'm just looking at B here, A there, P, so I'm looking at this angle. And again, remember you're rotating through C. Well, if I rotate this 180 degrees, and I know with rigid motion that the angle measure will be preserved, it goes right into this. And so what I recognize is that the rotation of 180 degrees of BAP would map to angle QPA. So QPA is representing the image of the rotation of the angle BAP. And if I'm looking at the rotation of 180 degrees of QPA, so let's rotate this 180 degrees about C of angle QPA. Its result, if we spin this around, would be BAP. So angle BAP. And because of rigid motion, we actually know that the measure of angle QPA is equal to the measure of angle BAP, which is a really nice result. Or in other words, now we've got our alternate interior angles equal. Okay, and if I have alternate interior angles equal, I know that my lines are going to be parallel from the earlier proof. So why is rotation with center C of 180 degrees of L equal to L prime? And essentially it's because the AB would map to QP, and QP is L prime. So since lines map to lines, we know that point A maps to P, point B maps to Q. And so if you think about this, rotation centered at C of 180 degrees of the line AB would have to map to the line PQ. This is the line L, this is line L prime. And so essentially we've proven what we want. And so we've just proven that a rotation 180 degrees takes L to L prime. And we can summarize this below. So we have our theorem. Theorem: suppose transversals intersect a pair of parallel lines. If alternate interior angles are equal in measure, which is what we just had there in pink, then the lines are parallel. Okay. Huge result for us. We're going to pause, let you summarize what's just happened. A lot of proof going on, very heavy. Please write down any questions you may have. Do not hesitate to email, and I'll do my best to get a hold of you. Thank you.